Today I want to dive a little deeper into making underwater shots. I iterated on the setups from the last video and created this shot which we're going to make together. Here's what we'll cover. Creating custom velocity fields for affecting the marine snow, which is those dust particles, and way more detail about USD composition with Solaris, setting up render passes with KarmaXPU, including custom Cryptomattes, and compositing in Nuke using those render passes. I said at least two things in the last video which require some revision. Number one, the dust particles can just be slapped on there and be fine. And number two, the propeller needs some kind of cavitation effect to help sell the movement. It's hard to find real images of attack submarines moving underwater for obvious reasons, but going through movie references, Hunt for Red October was one of the few where they really went all out with the propeller effects, and comparing it to the other ones that just had the prop spinning with motion blur, I, for once, like the simpler look better. It seems like the big thing selling the motion in a lot of these shots is the way the marine snow interacts with the sub and how it whips past the camera when it's moving. Alright, so let's talk about this marine snow, and I created a new geometry object here which I'll dive inside. So this is basically two sims, and we'll go through both of them. The first one is basically just ambient particles sort of floating out there in the ocean that the sub is going to pass through. And the other one is sort of just to sweeten the deal a little bit, which throws some particles off the propeller itself as it moves. Let's go through the inputs to these sims and then we'll talk about how they work. So both of these sims, we're going to take the submarine, which is now animated and goes through the water. The propeller side of things, which is certainly simpler, we're going to break off the propeller, just sort of splitting it off with that group. And then we're going to manually create a group of these blade faces, which are facing backwards. And so now we can take those and use those for the simple sim, which is going to be just tossing particles off the back of this propeller. So we take those blade faces, we do a little bit of an adjustment to the velocity here, because if we set it as the normal or something, that's going to be pointing in weird directions. And so what I want to do is use the normal, but I want the velocity to sort of bias itself backwards so that things shoot out of the propeller this way. And so that's sort of just an adjustment here. This code basically does that. And then if we dive inside this sim, this one's very simple. So we're basically just sourcing that first context geometry, we're scattering it onto those surfaces. We're not really creating that many particles because we don't want a ton coming off the propeller. This is just sort of to add to the effect. And that's really it. Where the life expectancy is short here because we kind of want them to go away. We just want this, again, to sweeten the look. And we're just inheriting the velocity there. We have a pop drag on here with 0.85 just to sort of like give it a little bit of resistance, but still allow that propeller to throw these things around pretty quickly. So now let's go over the second one. The second sim is this ambient particles sim, which, as I said, is just particles floating around in the water. And we create that with just a bounding box and points for volume. We do a decent amount of particle separation and bump up the jitter there. So let's talk about the inputs for that. So we're still using this propeller, and we're going to come over here and we're going to put a point cloud on here. And then we are going to, once again, sort of bias that velocity to go back instead of, all over the place. And we're going to rasterize that velocity attribute. Now, we can't really see anything here. And the good way to look at any vector volume in Houdini, like velocity, is the volume traillet. So I just have this connected to the volume and this connected to that point cloud. And now we can see exactly what the velocity are doing here. And this we're going to take into our sim as one half of some velocity field that we're going to throw some particles around with. So this is just the propeller half of that. This is just for visualization. This is the actual object. We're going to take this volume and bring it into that sim. Now, the other side of this is we're going to take everything but the propeller, which is the body of the sub, and use this to basically create a field that has a slipstream basically around the sub. And I'm breaking that into two pieces. One is the bow and one is the rest of the sub. So if we come here and we look at the velocity field for this, same deal here, right? We're going to look at this as a velocity field. So you can see that the velocity trails are pointing slightly off the sub. They're not just going right along the body. They're kind of like porcupine spines here. And the ones on the bow, they come off the most. And that's because the bow displaces particles the most. And so what this code here does is I can choose, how much I want that to fan out. So that's all that code is doing. We're taking the dot product between the normal and the velocity and saying to bias it in this direction, and then also give it a little bend there. So that's what that does. And we do the same for the hull. I split those off independent of each other because obviously the hull doesn't do it as much, the bow does. And so I can control that there. And those are going to be merged together. So we have a single velocity field here with all those things added to it. We are once again going to rasterize velocity here and just kind of mess with these settings until we get something that is high enough resolution. And that's going to come out of here. So now let's go into this ambient particle sim. In here, we've got our points from volume, and we're gonna go source those. We're gonna source the first context geometry, but we're gonna use all points. We're gonna come over here and we're only gonna activate this on the first frame because we want these to just stay. We don't wanna birth more particles, they're just gonna stick around. Life expectancy is pretty high here because we want them to live, throughout the entire sim. Here's where the big things come in. So we're taking those fields that we just created and we're doing, once again, our pop advect by volumes. And I have two here just because I wanted to change the properties just a little bit on these nodes. So this one has, the one that has the propeller is the velocity is higher, the velocity scale is higher. And on this one, the advect body, it doesn't drag it as much, and the velocity scale is a little bit backed off because the body doesn't throw things as much as the propeller. So this is going to be the propeller and the body pushing all this stuff around. We have a pop force here, which is basically just to give these a little bit of ambient motion so they don't just start still and they don't move around unless the sub interacts with them. So that's just sort of to get that floaty feel. The other big thing here is we have a collider. So this is a static object, and I'll show you what the collider looks like here. I've basically just created a small thing here where we're getting rid of a bunch of attributes that we don't need. And this is really just the geometry of the sub, but we're also doing a VDB from polygons here, which is like reasonably good resolution, but this doesn't need to be awesome. It just needs to be there. And that's going to be the other collider object that we use. So if we go back into the ambient particle sim, we set this up with the geo in the SOP path here, the geo collider. We are going to use deforming geometry because the sub is now moving. We need to check that so that it uses a moving collider. And then down here in collisions, we're going to change this to volume sample max axis. And we will put in that volume, that SDF here, as the proxy volume. And so that's going to make sure that we have like a pretty high res collision. And you can see it here if you turn on the guide. Like it's not exactly there, but this is really close. This is as close as you would need to get. Even this is probably too high res, so you can back this off a little bit. So that's going to move through, and that's naturally going to collide with our particles. So that's going to give us some of that motion, and then the rest is going to come from that sub, the velocity field that we added there in the advect by volumes nodes from the propeller and the body. So once we're done with that, we're just going to do similar to what we've done before. We're going to DOP import those things from each sim. We're going to merge all that together. We're going to delete a bunch of attributes because we have a ton here. We're going to cache this to disk. We don't want all that stuff. We're going to delete some groups, and we're going to do the same thing that we did with the particles in the last one, where we initialize this random normal. We don't care what this is because all we're using it for is to get the particles to tumble. This is exactly the same code as we used last time. We're also going to give it that random particle ID. Again, same thing. And the particles are over here. I just took these from the last time where it's just, a simple sphere with a little bit of noise added to make it look weird. And then we're also giving those a piece ID in piece 1 and 2 so that we can add them to copy to points with that. So that's going to give that 1 or 2 or 3, I guess. And then here is the scale. And this is just a scale adjustment so that we can, establish a global scale, which is obviously going to be pretty small. And then we can sort of control the distribution of small to large in here. And that's going to be cached out to disk. And we are going to then basically just put a null on there. And then the rest of this, I have this little visualizer over here for speed because I like the way that this looks when we can visualize it with a, nice looking plasma field or whatever it is over here. So that's just the magnitude of the velocity. It makes it easy to do a ramp. This is ramp from attribute speed. And so we can just visualize that. And then here we are copying to points, and I'll put on my test camera here. So we're just taking that particle stack of those two that we have available, and we're gonna copy them to points and use the piece attribute there so we get that random particle assigned to each. We're going to cache that out as a geometry, and that's going to be our particles that we bring over to Solaris. Alright, over here in Solaris, I basically just tried to simplify and optimize the scene as much as I could. What I started with was replacing that procedural water business with just a Karma fog box. Since we don't see the surface of the water, we don't need to worry about rendering that. And this is a lot cheaper just for this depth look. And obviously it's just the density and the color that changed, same as last time. From there, I kind of just started caching out a lot more of this stuff to USDs and bringing it in as references. This one still isn't. I added a couple of more assets to get these rocks in here and stuff. These are assets from Fab, previously Megascans. And I just did all those with Component Builder to get those loaded in as assets as well. I changed my lighting setup a little bit here. I have a sky, which is just that HDRI. Instead of doing a directional light, I did this trick where you can basically make an aerial light giant, that's this thing, and get it to be your sun. And I just like, it was just quicker to get the look I wanted with that. It's a good idea sometimes. And just added this sort of light at the end of the tunnel spot to help kind of tell a story and give the image a little bit of points of contrast that would show the sub. I also, on these lights, did something which we're going to talk about in a minute, which is if you come over to the Karma tab here, there's an LPE tag, that stands for light path expression. And $OS just means that that value is going to be whatever I typed here. So this one will be called tunnel spot. We're going to talk about that in a second. The last thing I did was I animated my camera in object context and just flew it in here with a scene import, and then added that to the render settings as the camera. So now let's talk about render passes, because the light path expressions have everything to do with that. So if we come down to image input AOVs, AOV, by the way, stands for arbitrary output variable, which is just infinitely helpful. But what that means is basically you can split this image into different parts. And so these are the passes. Beauty is the main pass, like that's the whole image that you see. Then we have combined diffuse, we have glossy reflection, we have combined emission, combined volume, albedo, and we have some extra render vars here. We're going to talk about that in a second. So one of the things I've done up here is the beauty is now split per LPE tag. And that's going to mean that I'm going to have this beauty pass, but as affected only by sky, then only by area, then only by tunnel. And we can see what this stuff looks like here. And once you get the Karma view up here, if you click this, you can see all these passes that I'm talking about. So this is just lit with that giant area light. This is the light rays on its own. This is like the HDRI contribution. This is just the spotlight. And so that's kind of what we're doing here. So we want to break this up so that we have control over each of these things in Nuke, and we're going to go into that in a second. Let's talk about Cryptomattes. So Cryptomattes are like easily a topic unto themselves, but basically what you're doing here is when you have usually either an object or a material that has a name, when you say make me a Cryptomatte out of that, in this case the default is crypto object here. You also have crypto material. So when it's set to crypto object, you can see like something like Cliff 1, that's going to have its own Cryptomatte because it's got a unique name, and that's going to basically say, okay, make an image that basically just has a bunch of colors, kind of looks like a clown mask, and each of those object names is going to correspond to a unique and different color so that you can select those colors and make masks out of them. We're going to do that in Nuke. I couldn't use the defaults here because one of the objects that has an ID is this water volume, and it's all over the scene, so it just made picking little pixels from other things impossible. I'm sure there's a better way to solve this, but what I did was author my own Cryptomatte IDs. So one of the things that's awesome about USD is that you can script the absolute shit out of it. And you could rewrite an entire USD scene using Perl or something. And in this case, I didn't do that. What I did was just use attribute wrangles. And so let me show you, if you come into, if you just have a bunch of stuff on here, and you come into something like water particles instances, and you look in this window, which is called, in Solaris, scene graph details, you're going to see here things called primvars, like age, life, and these are actually attributes in like sort of Houdini world. Primvars are attributes in USD world. So they're going to grab the stuff that you authored in Houdini and put it in here. And sometimes the names change a little bit, but you'll see this one down here, primvars crypto name particles. This is a variable that I've added, and I just did that with an attribute wrangle for the particles here. And basically all you got to do is drag the thing that you want. And so everything under particles is going to get affected by this. And just do s at primvars means that's going to be a string. And then you make this up. I just said crypto name, and that equals particles. So if we do that for the cliffs, I have cliffs left. So everything on the left side is in that crypto ID. The right and the spire, I did it with the sub as well. And so now when we preview that, we can look at the crypto object pass, and all those things you'll see have a different color. So now I could just use a color picker and pick the right cliffs, the left cliffs, the submarine, and the particles, and have control over those individually. So with all that done, it's time to render it out. And what I would recommend doing is just take one frame at a time and do test renders like pretty frequently. There's a lot of ways to do that. Obviously, one of them would be here, just to make sure all the data you're getting is good before you do like a 10-hour render and end up with something that you didn't want. So you can do that. You can also come down here to the USD render op and render it out to mplay. There's a little picker in the corner. Sometimes the viewport is a little weird about some types of data, but it's usually fine. What I would really recommend is that you just export out a single frame, put it in Nuke, and start building a comp if you know that what you're doing is fairly comp dependent. A great piece of advice given to me years ago was like, ask yourself if you can do this in 2D. And to be honest, a lot of the shot could be just done in Nuke. Probably all the things that are very expensive to render out, like the water volume. You could get that from a depth pass. You could do God rays in Nuke. You can do all that kind of stuff. So shifting things from your 3D workflow to 2D can make a lot of stuff cheaper. Great example here is lighting. I could have spent ages tweaking the lights to get the exact look I wanted, which I would do in like an Unreal Engine project. Like if you see this shot, there's barely any compositing or color grading. This is what it looked like with just the lights in the scene. But instead, I just wanted to make sure what I rendered here was like enough data to make an image without like too much fiddling in Nuke. But it doesn't have to be perfect when you render it out. You just need to know that you have the elements that you need to adjust it to sort of meet your vision. The only other thing we got to pay attention to in this one is that instead of rendering out a PNG sequence, we need to render out EXR because PNGs won't carry the other data and the other passes that we have, EXR will. So let's jump over to Nuke and finish this up. So here in Nuke, we're looking at the beauty pass that we just rendered out, and you can see that I've got this split up in two ways here. The first way is with these sort of like regular passes. We've got our diffuse, we've got our reflections, we've got our emission, and we've got volume. And these are all just shuffled out. So shuffle node in Nuke, you just bring in your footage, and if you have layers, they will all show up here. So I'm just doing combined diffuse. You can see all these things that I exported from KarmaXPU here. So you're just basically taking each of these and merging them together with plus. Plus is important here. And then when you get here, you end up with exactly the same thing as your beauty pass. I chose to go with the reconstructed from lighting passes approach because I wanted to control that more. And so over here, I've got an HDRI pass, I've got a directional light pass, I've got our spotlight pass, which is like barely visible over here, but we'll see that more in a second. And I've got the light rays. So from here, I've got a lot of control over what I can do, and mainly I'm just grading these passes separately. So for this one, I graded just a little bit, took out some of the red, added a lot of green and blue. When you are grading underwater images, it's better to use the quote-unquote big knobs, like gamma, multiply, and offset, versus manipulating the color with something that controls a smaller range of values that can cause like banding and weird things to happen to your image. The other thing about underwater shots is the deeper you go, the less contrast you have and the more blue it gets. So just keep that in mind. So at every stage, I'm just kind of plussing these over each other. And you can see I've got this grade on the directional light, again, just kind of like making it more blue-green. My spotlight, I did change quite a bit. So that's like, you know, I'm just like pushing the gamma real hard on that so we can actually see it. And then in the light rays, not too much going on there, just a little bit of a hit. And then all those get merged out into this, which is our final sort of composite of all those things together. Next, we'll move down the line here a little bit and talk about Cryptomattes and how to use them. I graded these rocks because they're pretty red. So if I bypass this, you can see that they're kind of red and yellow. I could have fixed this in the shader, but the Cryptomatte works just as well. So for a Cryptomatte, we type in Cryptomatte, we get this Cryptomatte keyer node here, and we can just hook this up to our footage. And if I put this out, you're gonna see that this is just like a color chart like we saw when we rendered it out. And so to select something from here, all you need to do is make sure you're on the right layer. I only have the one crypto object layer, but you might have crypto materials, something else. Click on pick or add, and then control click anything in this image to isolate it. So that's how I isolated the rocks here. And so here we can see, yeah, I just graded those down a little bit, took the reds out a little bit more. And I'm isolating it there with just putting this mask into that matte because the selection is going to come out as an alpha channel there. Did the same thing with the particles, just kind of made a bigger deal of them. And like, it's pretty hard to see the particles here, but they have their own color, and you can just control click that, add them to that layer. So that's how I did that, just a simple crypto matte. And like, I just kind of, you know, I lowered the white point. I actually made the shader on these just a little bit emissive because I was having a really hard time getting that sort of like the lighting on the particles where they're not backlit and they're, you know, they're really, they're kind of bright. So I just brought those out because obviously they make kind of a big difference in our shot here. That's the whole thing we're talking about. And then from here, I just did a global color grade. You could just do this in Resolve, and I probably will go back and change it by the time you see this. And then I also just kind of desaturated it just a little bit to get it to be a little bit more kind of like Saving Private Ryan, that kind of look. Here I added a lens blur, like an edge blur. Some lenses will blur around the edges. This is like really subtle. You can barely see it, but that's what compositing is all about. And then here I did the same thing in the last shot where I give it like a little blur just overall because CG elements are kind of sharp. And then same deal with the vignette. And I did add grain to this one because I liked it. And that's about all there is to this composite. And here's how it all came together. Let me know if you have any questions in the comments, and as always, thanks for watching.